Yes. All right. So this is a little bit of a YouTube video I'm doing to follow up on doing written newsletters, which I've always do just to let people know about the farmers markets. I'm gonna lower my mic a little bit here. I don't know if it's better. Yeah. So I had did a really interesting newsletter I kind of liked. Am I doing this right? There we go. I don't want to be like blowing your eardrums out. So as I proceed to get close to the mic, so let's see, or I can lower here. Is that better? That better? Okay. So this newsletter I did was about how I learned something about global warming and massive rainstorms that we see as the as time progresses. And I found this interesting chart which explained why when I would make small changes to my dehydrator temperature by increasing by 5 degrees, 3 degrees, I would see the product becoming very, very over dried, especially with vegetables, which are more sensitive to temperature and over drying and excessive heat. Um, so this is a particularly interesting chart from this website, Engineering Toolbox, and it shows this exponential curve of the air moisture holding capacity, pounds of water per 100 cubic feet of air. And it's quite amazing, impressive, and how you start to get at really, it stops at 100. I don't know. You can extrapolate kind of, and I it may become more linear, but yeah, so then I kind of found this to be one factor that was causing the overdrying. And then chatting with my dad, who has a master's in mathematics, he said, well, look into the evaporation rate because not only can the air hold more water, but the water is evaporating faster, so that will also contribute to your overdrying. And he was right. And so here's the evaporation rate. It's kind of truncated. It's kilograms of water per square meter per hour. And here you also see some curvature going on. Um, and I have an analysis. This is my newsletter from 2023 March. And then I did a bit of a follow up. Or no, this was the previous. I did a previous one. Let me see here. Ah, this is the second. Um, yeah, basically. Then so here we go to today, and I decided to use Claude, which is an AI chatbot, and it does really nice charts. And uh, here I added on wind speed, and it really provided an interesting layer of depth. So just to summarize, basically, higher wind speed, which is the red line is the higher wind speed at 30 miles per hour, and typically ambient air has some airflow. Maybe you're outside on a calm day, so it's 5 mile per hour wind. And the difference between dashed and dotted, it's a bit confusing, but it's not when I explain it. Just you would normally go with dashed. Dashed is if you were to heat the air, it gets drier, and so it has the ability to evaporate the water faster. So normally you wouldn't maintain this same relative humidity because it would require adding moisture to the air. So actually, your relative humidity is dropping as you heat your air up. So that's why you see the evaporation rate of the upper curve is a lot higher. You can evaporate faster. Um, so that's the distinction. Um, I would probably remove it, but I'd have to subscribe to Claude. But I did maximize usage here. It actually might be quite worth it to pay for this chatbot. With that being said, I did a little bit of a numbers analysis also, uh, dig in a little bit more, but not too much. And yeah, so kind of looking at number wise, if you were, I don't want to go too in depth. You can hover your mouse and see these numbers. Basically, at ambient temperature, you have this. 0.046 kilograms per meter squared per hour. That's over here. And then if I increase to 92 Fahrenheit, the same air, you're increasing your evaporation rate by 178%. Quite an increase just from 72 to 92. And then, interestingly, if you were to now add 30 miles per hour of wind to that 92 Fahrenheit that was at 5, instead of going up from 178, when you're really blowing the air, it's 833% increase in the evaporation rate. So I learned something here that airflow. I mean, I already have a gigantic 5.25 foot fan in my dehydrator, which, for those who don't know, I built the world's largest DIY from scratch food dehydrator. I'm a food scientist, a food scientist at Cornell. Used to work at for a bunch of different companies. But yeah, so this is kind of interesting to me, and I never quite understood the level of importance of high airspeed, and I kind of have an idea. Perhaps now I will max out my airflow in the beginning of the batch and then drop it down later as the product gets dry and has a tendency to fly off the trays, which is bad. So I have to add a capability to my machine to lower the fan speed, um, and perhaps that will help keep the product in place and optimize, use less energy overall and reduce the batch time. So then one more interesting look was if you go at 122 degrees Fahrenheit at 30 miles per hour, which is sort of why I dehydrate fruit at this setting. You're looking at, just interestingly, obviously food's dehydrating as compared to ambient, 2,624% increase in the rate of evaporation of the same air mass, just hotter and moving at 30 miles per hour, I believe. This was 1.253. Let's double check. Uh, 30 at 122, 1.253. Yeah. So goes to show you how efficient a dehydrator is. And that's not even at, a hot temperature. That's a very mild dehydrator temperature. Um, yeah, and I did a couple more interesting looks just to compare how slight increases in temperature. So you're from 118, where you might gently dry a fruit or vegetable, to 123, you're doing a 4% increase in temperature. The evaporation rate, however, is going up by 17%. So this is my observation. And this, I don't know, does this take into account air capacity? I believe it does. This should take into account both evaporation rate of the water and the air capacity. I want to dig deeper into this AI just to confirm it has taken into account both those factors. But basically, if you were to compare the 17% over 4%, that's a 300% greater change. So that's just indicating it's not a linear. If this were 4%, this would be 0%. So yeah, and then I just was curious, what if you went hotter, way up at 140 to 146, which is about a 4.24, it's 4.29. It increases 17.9, so more. So it is this, the curve is sloping upwards more here. That's what you would expect. So it's 318%, 17.9 over the 4.29. So it is the difference, the impact is greater when you get to higher temperatures. And then at the highest of my dehydrator, it's up to 332. So you see the curve is steepening over here. And presumably in an oven, if you were baking, this change of this percent change in temperature, let's say going from what would be, let's say let's say 450 is a very hot oven, uh, times 0.96, 432. So you wouldn't even, would you go from 432? Potentially, you might go from 425 to 450. And yeah, I could see how that would cause a tremendous increase in the drying of your food. So something to consider. And I think 350 to 375, that's done a lot. That as far as a percent is a 7% increase in temperature. So that's a large change when you're cooking in an oven. So yeah, so maybe next time I'll do a follow-up chart. Maybe I'll actually pay for this service. I don't know, but it might be worth it. And thank you for listening. And hopefully I'll see you in the farmer's market or check out my products. And hopefully leave your comments. I'll leave comments on this YouTube video. All right. Thank you. Bye bye.